How's it going there, pre-calculus people? Welcome to lesson 4.7, um, inverse trigonometric functions, which we will just call inverse trig functions. You'll be happy to know that this week there'll only be one video, and it'll be the shortest video we've had all together. We have a fairly nice topic to discuss this week and keep things pretty straightforward. So I'm sure you're happy about that because you're going to be like, Mr. L, you've been just going on too long and 2 videos and 3 videos and 4 videos. I get it. You know how I am. I just can't let things go sometimes. Well, this week, it's push right on through. What you see on my boards today is all we have to cover. There's 6 examples. They're all very interrelated. But the worksheet you'll receive this week, that it's exactly organized in the way that I have organized these notes. So, the first 3, you are either told the sine, the cosine, or the tangent of an angle. You have to understand, if you've kind of forgotten, got rusty over these weeks of not being on a regular schedule, the A and the R and the B here, and I just chose random letters because it doesn't really matter, those are angles. You know how sine was opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent? Okay, I'm giving you what that would have been if we had divided it out. I'm telling you there's some angle A in some right triangle, and the opposite side from A divided by the hypotenuse in that triangle comes out to this. We're going to use, and this is very calculator driven, we just can't do this mentally. We're going to use our calculators to do so. Now, remember, you don't have to have a graphing calculator if you have just a regular TI-30 or something basic, or Desmos on your laptop, on your Chromebook. Number 1, if you are using any type of calculator, now I'm using my TI-84. If you look, one of the settings right there, the 3rd setting down says radians. I need this in degrees, so I'm going to fix that a minute. Because when you do inverse, you want it to spit out the angle in degrees. So that means every time we do inverse, sine, cosine, or tangent, we're going to hit second sine, second cosine. You'll see the things above the sine, cosine, tangent buttons that say like, that's kind of blurry, isn't it? Sine to the -1, cosine to the -1, tangent to the -1. That's terrible notation in my opinion, but it means inverse. So right now for this first one, I'm literally going to go second sine 0.8741. And when I hit enter, it's going to tell me the angle that would represent in any right triangle. On the worksheet, I've asked you to round off to 2 decimal places. So this angle A came out to 60.94 degrees. Okay, next one, inverse cosine. Second cosine, 0.7143. And that spits out the angle that would have that cosine. That means an adjacent divided by a hypotenuse came out to this decimal. That makes sense because the adjacent has to be smaller than the hypotenuse. The opposite has to be smaller than the hypotenuse, so the number comes out less than 1. 44.41 degrees. So angle R, 44.41 degrees. And then last but not least, now tangent. See, tangent's opposite divided by adjacent. See, the opposite can be bigger than the adjacent. The opposite can be smaller than the adjacent. So tangent doesn't have any restrictions on this, where sine and cosine do. Sine and cosine have to be less than 1, or 1 or less. Because you're always opposite or adjacent divided by hypotenuse, and hypotenuse is always the longest side. So that's the deal there. So this one, if I do inverse tangent, 6.9971, enter, 81.87 degrees. So you guys, that's just basic Here it is, do the inverse of this decimal, tell me the angle that would have fit this scenario. So that's one part of the worksheet. The other part is I give you a triangle. I give you specifically a right triangle, otherwise none of this makes sense. Can't do sine, cosine, tangent without right triangles. And I'm asking you to find one of the angles. I'm only giving you two sides of the three, and it's your job to pick the appropriate inverse, sine, cosine, or tangent to do it. Each case I have an angle marked with a question mark, and that's how we make our decision. So if you look at this first picture, we have our right triangle. This side right here is my hypotenuse. And based on this angle right here, that's adjacent. This side, which would be known as the opposite from the question mark, not in play. So adjacent hypotenuse, folks, that tells us it's inverse cosine. Now the way I usually write that on paper on the board, I would write it like this. I would use that inverse cosine notation, which is cosine to the -1. I don't like that because I feel like a -1 exponent has a different property in other problems. So again, poor choice of notation, but it means inverse cosine. In cosines, adjacent over hypotenuse. Adjacent 7, hypotenuse 12. So this time I'm using the actual fraction. Instead of like this one, I just gave you a decimal and say, hey, figure it out. Well, this one, if I go inverse cosine, 7 divided by 12. See, it'll look like that on your screen. And then you hit enter. Same as before, give me the angle to two decimal places. That's 54.31 degrees. 54.31 degrees. Alright, struggling here. That doesn't erase as nicely as my board in my classroom. There we go. 54.31 degrees. Okay, same situation over here, people. We have an angle right there marked with a question mark. Right here's the hypotenuse, so I'll mark that with H right away. This is across, so opposite. That's not a 0, that's O for opposite. So this is opposite in hypotenuse. Opposite in hypotenuse is sine. So we're going to do an inverse sine of opposite divided by hypotenuse, which would be 13 over 24. So this time I'll do inverse sine 13 over 24. Again, just so you can see it. Enter. 32.80 degrees. I'm just rounding to 2 properly because it says 32.797. So because that third number is 7, I round out from 79 to 80. So there we go. Last but not least, folks, we have this right triangle again. Please note the other two, I always label hypotenuse right out of the chute when I see it. Well, this time the hypotenuse is right here and it's not in play. There's not a number there. The angle I'm asking about is right up here. That's adjacent, right next to it. This is across from it, so opposite. This is an adjacent opposite, opposite adjacent situation. That's tangent. So inverse tangent of opposite over adjacent. 23 over 10. So we'll do inverse tangent, second tangent, 23 over 10. Again, just so you can see the third line, that's what it'll look like. Enter. 66.50 degrees. And that's pretty much it for this week, people. Like I said, it was going to be pretty straightforward business. This was a short video. I'm not even to 10 minutes yet, which is great because I know some of the other videos were in the 20 to 25 minute range, and there was 2 or 3 or 4 of them. But we were hitting some pretty heavy stuff there that I needed to explain carefully. So we have a nice break this week. Not saying they're all going to be like that. We have some other stuff that we're going to try to cover in the weeks to come, but we're trying to stick to one topic per per week. Oh, just went over the 10-minute mark. My goodness. All right, you guys. So I hope you have a good week. And hopefully this is pretty straightforward and friendly for you guys. All right? Take care of yourselves.